Let us look at another example of a line integral. And we're going to use Green's theorem to solve it. But we will first use direct line integration. And we get our answer. Then we use Green's theorem and we should get the same answer. Now, of course, line integration is usually longer and a lot more work than Green's theorem, alright? But we'll look at both. Hopefully you won't get examination where you use line integration because of the amount of work going into it, right? You could get it as a homework assignment, but when you get this type of question, hopefully it will be just Green's theorem you're asked to do. But anyway, let's look at this. You need to evaluate this integral. It is the integral along a curve going right around a region of, this is a vector field, xy squared plus x squared dx. That's the horizontal component of the vector, that's dx, plus 4x minus 1 dy. That's the vertical component of the vector. So the vector would be like this. Alright? What? This is the horizontal component and this is the vertical component. Alright. Of each vector in the vector field. Now you need the region. What's the region? Now you could be given the region something like this. Around the region formed by x is greater than or equal to -3, less than or equal to 0, and y is greater than or equal to 0, less than or equal to some formula, whatever it is. But in this case, you are given that you should do it around a triangle with vertices. Now the vertices are at A at -3, 0. The point B is at 0, 0. And the point C is at 0, 3. Alright? So you get these as the vertices. Now, I have done some examples before this one. So I want you to use what you have learned from watching those examples and what you have learned otherwise to complete this integration. A, by using direct line integration, and B, by Green's theorem. Okay, so go ahead. Okay. So you have completed it using both methods and got the same answer, right? Now, let us see what's going on here. We want to sketch the shape or the region. Say this is your xy coordinates. Now, let us say that we have 0, 0 here. We have negative 3, 0 here. And the other one is 0, 3. Okay, so what we have now is one side going this way, other side going this way, and this side going this way. All right. Now, what we do, we go around the triangle in what is called a positive orientation, that's clockwise. If you walk around the region, you have the inside of it on your left. All right? When we reach Green's theorem, we're going to do that. Now, here, A is here, B is here, C is here. So, we're going to integrate using direct line integration. With direct line integration, you have to be dealing with each component of the curve. In this case, it's a set of straight line, but it's still called a straight line, a curve. All right? Now, let's go along AB. From A to B. What happened? When you go along A to B, and just before that, remember, in this case, we are going to integrate, but we have a problem. You have x and y mixed up together. It's either you use only x or only y's, but no x and y mixed up. We have dx and we have dy. So if you use only x, you're going to have dx. You have numbers, of course, right? Like the 4 and the -1 and so on. If you're going to have only y's, then you have dy. But as I said in previous videos, I see where in many cases, teachers want the students who are doing this to use parameter, or the authors of books, they use parameters. All right, so we could use a parameter. T is a popular parameter. All right, remember, para mean alongside, meter mean measure, so you're using a new letter, a new variable alongside the variables that you already have. That's why it's called parameter, right? Now, here we have x to change to t, to write in terms of t, y to change to write in terms of t, dx you want dt, and dy you want dt. So, examine the curve. In this case, x is equal to, what is x? Well, so let x be t, because you have x that keeps changing. So x is t. Going along this section of the curve from A to B, right? You have x as -3, then it changes constantly until it reaches 0. What about y? What happens to y? Y is 0, because it's moving along the x-axis, so y is always 0 and it doesn't change. So that means dy is 0. Y doesn't change. You'd have to go up or down for y to change, but it doesn't. It remains flat. What about dx? Well, if you have x equal t, and you differentiate and find dx with respect to t, dt, you get 1. So you, dt, you get 1. So when you multiply both sides by dt, dx is equal to dt. You see that? Alright, now let's write the formula. We have the integral of xy squared. So you have x, which is t, y squared, which is 0 squared, t by 0 squared, plus x squared, so plus, but we want t squared, we're writing everything in terms of t and dt. Then after that, have dx, but dx is dt, so this is dt, alright? Plus 4x minus 1, so it's plus 4t minus 1, and then dy. But what is dy? Dy is 0. Alright, so here t, we have a change in t. Now if you talk about a change in x, is from -3 to 0. But a change in x is the same as a change in t because x is equal to t. So you're integrating from -3 to 0. See that? Now, what do you get when you do this? This is equal to the integral from -3 to 0 of t by 0 squared is 0. So what you have is t squared dt. But guess what? You have 4t minus 1 times 0. See that? So this amounts to 0. This is gone. So you're going to work this part out. What do you get? When you integrate t squared with respect to t, you get t cubed over 3. And it's a definite integral, so you're going from -3 to 0. This is equal to, put 0 first, 0 cubed over 3 minus -3, next -3 cubed over 3 equals, this part is 0, so you have negative, but then you have 3 3 is 9, 9 3 is 27, this is a -27 over 3. The negative and the negative multiplied to give you positive. So 27 divided by 3 is 9. Okay? So alongside AB, you get 9. Alright? Let me just draw a little line across. And then along BC. So next, along BC. What's going to happen along BC? From B going up to C, you see that x is at 0, you know. This is x equals 0. And then y changes as you move up, but you're moving along the y-axis, which is the line x equals 0. So x is 0. So x is equal to 0. Now, it didn't move left or right. It went straight up. So there's no change in x. So dx is 0, right? Now, y undergoes a change. We can say y is equal to t, and then if you differentiate y with respect to t, you're going to have dy by dt equals 1. If you multiply both sides by dt, you get dy. You get dy is equal to 1 times dt, which is dt. So dy is equal to dt. You see that? Now, the equation for the vector field is the integral of xy squared plus x squared. So you have the integral of xy squared plus x squared. This is dx, but we're going to change it now. X is 0. So this is 0y squared. 0 times y squared. Y is t. So this would be t squared plus x squared now. But x is what? 0. So it's plus 0 squared. Alright? Plus. Then you have 4x minus 1 dy. If you have 4x minus 1 and dy, you want to change it to t and dt. You see here that x is 0. So 4 times x becomes 4 times 0 minus 1 dy. But what is dy? dy is equal to dt. So you write dt here. So now this amounts to the borders. We're saying that y is t. But where does y move? Y move upwards from 0 to 3. Alright? You see that? So we're going to integrate this from 0 to 3. So this is now the integral from 0 to 3 of 0 times t cubed is 0. 0 squared is 0. So the dx part is gone. Now here, all you have is negative 1 left, because 4 by 0 is 0. So that part is gone too. So it's negative 1 dt. When you integrate this, you get negative 1t. And it's a definite integration from 0 to 3. See that? And this is the same as negative t. So we can put in the boundaries. The upper boundaries is 3. So it's 3 minus negative 1, 3 minus negative 0 with negative 1 times 0. But 3 minus negative 0 is 3 plus 0, which is just 3. With negative 3. So the answer here is negative 3. See that part? Okay. I'm going to draw a little line here so we can see the different parts of this later on when we look back. Now, we go along CA. We go from C to A. So we say we're going along CA. Alright. Now, we need to find out y equals. We need the equation of this line, the hypotenuse of this right angle triangle. Let's see something here. We know that gradient is rise over run. So the gradient of this line is the rise of 3 over the run of 3. Remember the positive, the line going from lower left to upper right, they have positive gradient, and this is positive gradient. If you move from A to C, or you start from C to A, C is the first point, and as you move, it would fall and negative. But if you move from C to A horizontally, it would also fall, so negative over negative, positive. See that? In other words, you could use the rise over run and deal with this. This is 3 over 3. Don't watch the negative 3. We're looking at measurements here. 3 units high, 3 units long. Alright? So it's going to be a positive 1. Another way you could do it is to say at A, the coordinates are negative 3, 0. So it's uppercase A. A is at negative 3, 0. And C is at 0, 3. C is at 0, 3. Alright? If you call this point 1 and say x1, y1, x2, y2, then the gradient is equal to y2, which is 3, minus y1, which is 0, over x2, which is 0, minus x1, which is negative 3. So it's 3 over minus negative 3 is positive 3, which is 1. So the gradient is 1. So the line is in the form y equal 1x plus c, but we need to find out what c is. Now c would be where it crosses the y-axis, which is 3. You can see it here. It is 3. So c is 3. If you wanted also, you remember you could put in one of these values and say y is 3 is equal to x, which is 0, plus c. So you can see that c must be 3, right? Alright, so what you have is y is equal to x plus 3. So if y is equal to x plus 3, is this line's equation y equals x plus 3. What you can do now is say we're going to let x is equal to the parameter t, y is equal to x plus t. Now what is dy? Well, we want dy, so if you differentiate y equal x plus t with respect to t, you get dy by dt is equal to 1. So when you transpose this to make dy the subject, dy equals dt. Alright? Now, what about dx? You need to write dt, not dx, not dy, not dx. It's dt alone you want. Now, x is equal to t. So, if you differentiate this, dx by dt is equal to 1. So, dx is equal to dt. Alright? Now, we're saying that the integral of, let me repeat this, xy squared plus x squared dx, xy squared plus x squared dx, plus 4x minus 1 dy, 4x minus 1 dy. Alright, now we want to change this up. X is t. So this is t. T should come here. The y squared. Y is x. Oh. Y is x plus t. Oh. We want. I wrote this the wrong way, you know. I said that y is equal to x plus 3. We know that x is t, so it should be written y is equal to t plus 3, right? So that part corrected. So y is t plus 3. Now, here, y squared must then be t plus 3 squared, alright? Plus x squared now. X squared becomes t squared. See that? Dx now, what is dx? Dx is dt. So, This is dt plus 4 times x, but x is t, so 4 times x changes to 4 times t minus 1 dy, but dy is equal to dt. So you write dt there. You see that? All right. Now, here we can simplify and so on. Oh, by the way, the boundaries are going from here to here. When you move here, x drops from 3 to 0. No, y drops from 3 to 0. X drops from 0 to negative 3. Alright, so I said that x is t. So whatever happens to x, same thing happens to e. X goes from 0 to negative 3. Alright? When you slide this way, you go from above where x is 0 and meet up with where x is negative 3. So it's 0 to negative 3. So you have 0 to negative 3 here. You see that part? I'm sure you're following, you know. So, and remember, as I said, you may not get a question to do the direct integration, not like this. Maybe it's just Green's theorem, but it's good to know how to do this just in case, right? Or you may get it as take home assignment, which might be graded, or maybe not even take home, you do it in class, whatever the case is, right? But you see, here, it's quite a bit of work that we have to be doing. In the next video, we'll do Green's theorem, and I promise you it will be shorter. Green's theorem will be shorter than this. But anyway, let's continue. This is the integral from 0 to negative 3 of t times t plus 3 square, which is t plus 3 by t plus 3 plus t squared dt minus 4t plus 4t minus 1 dt. Okay, let's simplify this. This becomes t squared. This is t by t give a t squared plus 3t plus 3t plus 3 is 9. So we could rewrite this inside the bracket here. It is t squared plus 3 and 3 is 6, t plus 9. Alright. When you multiply out the bracket now, what's going to happen? You're going to have t times t squared. This is going to be t cubed and t by 6t. That's going to be 6t squared, right? And then 9 times t is 9t. Let's get rid of this first t here because we had multiplied out the bracket already. What happens after this now? You have plus t squared. The thing is, you don't really need these brackets. Multiply them out already. And you say plus t squared. But then, 6t squared plus 1t squared gives you, it's going to be 7t squared. So this becomes 7t squared. Right, they're kind of bundled up together. Let me separate them. It says plus 9t. So I have plus 9t is 7t squared. Alright, good. Now this part, what we could do is just factor out dt from everything. and say this integral from 0 to negative 3 of, you have t cubed plus 7t squared plus, and we have 9t plus 4t is 13t, and then minus 1. Alright, so that's our minus 1 dt. We didn't need all of this space, so this is dt. And we're now ready to integrate all of this thing here. Alright, let's go ahead. This is t to the 4th over 4 plus 7t cubed over 3 plus 13t squared over 2 minus 1t from 0 to negative 3. Alright? Now, here, run out of scrolling space already. This is going to be negative 3 to the 4th over 4 plus 7 times negative 3 cubed over 3 plus 13 by negative 3 squared over 2 minus negative t, not negative 3, negative t. All of this minus, well, is going to be 0 to the 4 times 0 cubed and so on. So all of this amounts to 0. You see that? Now, here, 3 3s 9, 9 3s 27, 23s 27, 3, 81. This is going to be a positive 81 because negative 3 to the 4 means you're going to have 4 negative values. Alright? 2 of them cancel to get positive, the other 2 cancel to get positive 2. Over 4 plus, well, this is going to be a minus now because it's cubed. Let's get a calculator here. So what we have here, 3 3s 9, 9 3s 27. 27 by 7 is 189 over 3 plus, let's get back to our calculator to work this part out. Alright, so what we have is 3 3s 9, 9 3s 27. That's going to be, no, it's 3 3s 9. I mean, this is a negative 3 squared. 3 3s 9. 9 by 13 is what? 117. So that's 117 divided by 2 plus, no, t. I had written minus negative t before, but didn't move any further on that. This is minus negative, is going to be a plus. It's plus, but we're substituting the upper boundaries. So t is going to be, in this case, it's 3, because the minus negative come, I had accidentally written minus negative t, what is minus negative 3. When you change the t to negative 3, you get a minus negative t. No, minus negative 3. Oh boy. Alright. So, we work this out now. My. Alright. It's going to be take even more time and more work than we already done. So, let me just use my fractions calculator off the air. 781 over 4 minus 189 over 3. Oh boy, mosquitoes. Plus 117 over 2 plus 3 equal, we get 75 over 4. So that's what we get for this part. Now, what we want to do is add them up together. So this integral, let's give it a name, no? Call it int. So let me write int and not have to rewrite the whole thing. So int is equal to 9. Alright. Plus negative 3. This is minus 3. Plus 75 over 4. Alright, so this amounts to what? 9 minus 3 is 6. 6 over 1 plus 75 over 4. If you multiply 1 by 4, you get 4. Multiply 6 by 4, you get 24. So this is going to be something over 4. It's going to be 75 plus 24 over 4. 5 and 4, 9, 7, 8, 9. 99 over 4. Or 99 quarters. Alright, so that's what we got when we use direct line integration. In the next video, we'll perform the integral again, but we'll use Green's theorem.